Dave's here.
Dave's here.
Hello, I'm back.
You're back. Back to back on the podcast here, Dave. It's exciting.
It's an honor.
The honor is all ours, friend.
Yes.
Although this one, I think it's fair to say this one, we'd said we'd been talking about our episode on sagas, or been thinking about it for a long time, Adam.
Yes, true.
This one, a little more getting back into our groove of not planning more than a week in advance.
That's
sure.
Right. This is the hurry up offense.
This is the no huddle. This is the run and gun that Oxide and Friends is famous for. And so I also loved the comment. There was a comment from last week's episode. It's like, hey, I'm really glad to see that Oxide and Friends is back into the groove of not telling me what this thing is about for the first 17 minutes.
That was just building suspense. Like we did mention what it was about. We did.
On a re-listen, I definitely had some, hey, read the tweet, fellas, got vibes on that one. I felt like, hey, could someone define what a saga is? Fortunately, we did, but it was good.
We're building. We're building to it. You know, you got a sense of storytelling. Yeah,
exactly. You can't just rush in and say what we're talking about. That would be far too orienting. But so on this, to give the context, we are users of CockroachDB. So we one of the first things that we did, or early on in the company, is we knew we were obviously building a control plane. We wanted to have a data repository for that, and we embarked on an entire process. Dave embarked on a process, led the charge on evaluating different options for that, and we decided on CockroachDB, and for a bunch of reasons. And we haven't really talked about it much, I don't think. I mean, I think that the most we've talked about it, and correct me if I'm wrong, but I think, Dave, the most we've talked about it is in your Debugging Odyssey episode.
I think that's probably right.
And I don't know that we've talked about it publicly very much, because just based on the number of RFDs we made public for this. So we hadn't talked about it very much, but not deliberately. I mean, it's not that we were, we had mentioned it, obviously, and but then fate kind of forced our hand, because Cockroach Labs, which famously or infamously had taken an open source project and started to relicense aspects of it under the BUSL, the business source license, decided that they were going to go all proprietary on Thursday morning, right, Dave? I think it was.
Yeah, I think that's right.
So we obviously this is an issue of great interest for us, and had a conversation about it obviously on Thursday morning, and then I wrote up an RFD that we made public on Friday morning, and included in that, Dave, we made public all of the RFDs that you've done, 53, 110, and then your cockroach evaluation repo. That kind of took people through the entire process of why we decided what we decided, and then also what we were deciding to do with the move to a strictly proprietary CockroachDB in RFP 508. And I mean, obviously, it's like, we are a podcasting company that LARPs as a computer company. Did you see that Hacker News comment over the weekend?
I did, actually. Good for them. I mean, it is our joke,
first of all, I lolled at that. I thought that was a funny comment. I thought that was a very funny comment. It was on the Hacker News thread about this. Or maybe it was on the Hacker News thread, actually, about the RFD. Anyway, I thought it was very funny. One of our defenders was which I totally admire, was calling him out on it, but for whatever it's worth, I lolled. I thought it was funny. But that's, I think that our defenders probably right that this is someone, it's probably one of our detractors, one of the members of the Haters Club, who knows. But we got the RFD out there. The RFD got more attention than I actually thought it was going to. Is that naive?
No, I mean, I assisted in no small part by friend of the pod, Kelsey Hightower, who had just such a delightful repost of what you had done. Like, quote tweet, with just heaping praise, like almost too much praise, like suspicious. But
I feel that you were suspicious. I feel like your first thought was Brian has hacked Kelsey's account.
Well, I had to expand it to see if it was like a placed advertisement.
Logged in around the Oxide office, and and that little mischief maker has gone in and tweeted out. It was very fulsome praise from Kelsey. Really, I mean, honestly, it's like you always are. It's always very meaningful to get earnest praise from people that you hold in high regard, and obviously we hold Kelsey in highest regard. And that was really unexpected. It was delightful, but very unexpected to get. And I think also, I mean, it. RFD 508 is, I think it did a good job of kind of explaining our options there and our decision. But I actually think that the bigger piece of this, I mean, obviously the bigger piece of this is, Dave, the work that you had done in RFD 53 to define the rubric, and RFD 110 to describe why we selected CockroachDB. So I do want to hit on all of that. I feel that I mean, I don't want to overly fixate on the action of Cockroach Labs here, but I also feel that I would not be being true to myself. I actually, and Adam, there was one comment online. It's like, oh, I love this RFD because there's no there. What was the line? There was no tearing of the garments.
Yeah, right.
The rending of the garments. That's right. And you're like, yeah, wait, well, tune into the podcast.
Yeah, I mean, but does it make sense to sort of go into the time machine and dial it back to whenever it was 2020?
I do want to go into the time machine. I think before we go into the time machine, I just want to get it out a little bit. I know this is where it's like this is Odysseus being asked to be tied to the mast here earlier. You're like, okay, now untie me. I know all those things I said about the mast. Now untie me. Just so, because I do think that, I mean, and I described this, I had a P99 Conf talk that we then had a podcast episode on of the kind of the update to corporate open source anti-patterns. And, I re-listened to that talk over the weekend just to kind of remind myself what I had said, because we did call out Cockroach there in a positive way for the business source license, the way that they defined it being relatively crisp, actually, not even relatively crisp, crisp. I do think that the concern on all of these relicensings, and this one also, is not I think Cockroach has the indisputable right to do it, and they certainly, we want them to have a thriving business, and they've got a right to build a thriving business. So I definitely understand that. I think that you always have to be mindful of social contracts. So that's kind of the question: is where are the social contracts here? And I don't think they've got much of a social contract with Oxide. I think they've got, because, and Dave, you've talked about this a lot just internally, but they delivered they have developed an engineering artifact, a software artifact that's been really good, and they definitely don't owe us things. So I think that the social contract with Oxide and with other is pretty minimal. I think there's some other social contracts here that are probably more important that I can't really speak to. So I mean, it's I in particular, I do think the most important social contract, and maybe the answer is just there's no one in this category but are contributors to CockroachDB. I think those are the outside contributors. CockroachDB is in many ways the most important social constituency here, because their work was made available under one set of terms, and now it's being made strictly proprietary.
Yeah, I think there's another question it raises about what the direction of the company is. Who is the company? And this is not to answer for other people and with regard to Cockroach Labs, but what does it say to us, and how does it affect our use of it? And in particular, in this case, for us, some of the terms around it, like unlocking at 10 million ARR and some stuff like that, just was signaling in such a way that, to me at least, indicated a potential of future greater incompatibility between values or between our use case and what they intended.
Yeah, and that's a good point, Adam. And I do think so. Something to elaborate on just before we step into the time machine, because we talked about would we? Let's take a look at what's kind of available, and they do have a source available, CockroachDB, that is not licensed, but there are two requirements on there that you mentioned the $10 million of annual revenue, and that you have to be less than $10 million of annual revenue, and then also you have to have mandatory enabled telemetry, and that's an absolute non-starter for us, like a 100% non-starter, because our customers are deploying in potentially air-gapped secure facilities. It's like, that's a hard nope.
Like we don't even get telemetry from our customers.
We don't get telemetry from our customers, exactly. So you definitely don't get telemetry. Sorry. So it's like, okay, why not license it? And I think that a question that came up online is like, all right, so just like license the thing. And we cannot encumber this product at all from a software perspective. Every bit of software that we have in this product, we have to have a perpetual royalty-free license for. And it's not impossible that you can negotiate that with Cockroach Labs, but I would say it would get them, I would say, out of their sweet spot and probably out of where they want to be.
I think it's impossible. I think it's impossible in terms of like, there's just too big of a gap between what we would conceivably pay and like what would make sense for them to bother doing. Like, and we just like, I don't think it's a use case that they particularly care about, right? It's not what they're trying to preclude. It's not what they're trying to enable. It's not big bucks for them.
Or should care about. Like, this is like, don't like, please let us be in our own filth here. You do not want to. So we got other like aspects of the problem. Like, so our software is going to go out to a customer and it's going to run for potentially a long time. And we can't make real guarantees. Like, that can be pretty down rev with respect to CockroachDB. And so you can't really tell us like, oh, by the way, this is out of the support window. It's like, sorry, bad news on that. And so just a bunch of other things, like we're going to take you out of your sweet spot. So we're not, almost does not make sense, but it's very important for us because we need to make sure that one, we take the responsibility for being able to understand any misbehavior on the rack. But then also it's really important because we need to have control over our own pricing, and we need to make sure that we are a big part of the Oxide value is all the software that's built in. So that's why that's kind of why that's a non-starter, and kind of where we landed on that. So with that, I think we can step into the time machine.
There we go.
I think exactly. Now I've been coaxed in a lot, like
rending of garments,
drugged into the plane. Yeah, right. Exactly. We render the garments. So Dave, I think it is worth. So there are a couple of reactions online. I don't know, Dave, how much you were looking at this. There is definitely why didn't they just use Postgres?
Oh, really? I hadn't quite seen that.
Yeah, I kind of figured you hadn't.
You're like blindsiding him with this.
How much time do we have?
I am blindsiding. Well, no. It dovetails into a question that Dave had asked the two of us, Adam, which is like, may I spend the first 45 minutes talking about Postgres?
I think I said 90 minutes.
You said 90 minutes for sure, right?
Did you say 90 minutes? And Adam's like, of course, because Brian thinks that 90 minutes is 45 minutes. This is why I've got so many domestic problems, because this is why
it's all
I promise
sense.
Everyone it's right. It's all making sense. Brian thinks his podcast is 45 minutes long. Like, that's the problem. I think we actually found it. So Dave, I think it is worth talking about why our experiences with Postgres, and you've got, a line in RFD 53 that is, you've got, there are some, whatever a subtweet is when it exists as a line in an RFD, about Postgres. But you want to talk about our experience with Postgres a little bit, and positives and findings.
To be clear, this is your experience at Joyent.
That's
Joyent.
Right. Yeah. And so I'm not sure how far back in the time machine we want to go. But I want to give at least a little bit of context. So certainly the whole process of figuring out what we were going to use for the database here was heavily informed by having just previously come off of several years spent most of that time fighting issues productionizing Postgres databases.
If I can interject, Dave, every time I would go over to your office for lunch with Brian, no joke, you'd be in some Postgres firefight. And just that's every time I would
come to lunch every day. It would have been.
Okay, good. I just
every time I visited you guys in your office, you were in your office. Yes, it was.
Yes, we were doing the work that we do every day. That's what. Anyway.
Yeah, that's what we were doing.
There was a lot of that. So this started, back at Joyent, we built a system called Manta, which the sort of short version of it is it's very similar to Amazon S3 in spirit. It's an HTTP object store, put, get, delete of large blobs. And some things that were different that turned out to be pretty relevant for many reasons is that it was strongly consistent at a time when S3 wasn't. So if you put something into Manta, you would get it back out, which required a strongly consistent metadata tier that we'll get to in a second. And it also imposed a directory structure so that you could list the contents of things efficiently, essentially. And so this thing, I'm going super fast, but the implementation is basically divided into storage and metadata, right? The storage is durably storing these large blobs of data, which you would not use something like Postgres for. And then metadata is this gigantic database mapping user-facing names to the underlying storage objects that contain that data, right? And of course, it's a cloud service, so we need high availability. How do we build high availability? Let me get back to that. The other thing we need is horizontal scalability. And so we ended up going with Postgres largely on the strength of its reputation around data integrity and performance and just general rigor, right? Is that your recollection, Brian?
Do I need my lawyer present? It feels like I felt just a little bit pointed. I unfortunately, I fired Adam as my postmortem lawyer after the last postmortem in which I was hung out. So I need a lawyer here. I'm going to have to go with the public defender. Actually, wait a minute, Dave, you're the public defender.
I think that's right, though. I mean, I think we didn't do a lot of testing or I don't know how much we did a serious survey of alternatives, but it seemed like the thing to beat. It was like, well, let's try this. What else will we use?
It was what we did it on vibes. Absolutely. Yeah. It kills me to say it, but we did it on vibes and reputation. And we did not dig into that reputation at all, really.
And I would say that's how most people make technology decisions, though. Like it's expensive or perceived as expensive to do a rigorous analysis, and going with the consensus approach makes sense in a lot of cases. And I mean, until it doesn't.
Yes. And I feel that if you had frozen time and said, hey, wait a minute, you guys are doing it the wrong way. Don't you want to do something more rigorous here? I don't know, Dave. I mean, I've got way more faith in you than me. I think I would have been like, no, but we know all these people that are using it. And of course, our kind of do you know it? Do you know it? Know it? What do you know?
Asked them?
What do you think you know? Well, what do you think you know? Have you, because so I think that you're right, Adam, that this is the way lots of people make decisions. And I don't know that we thought it to be as flawed as we now know it to be.
And even in the end, it's kind of a mixed bag. I mean, we made it pretty far on that decision and those vibes, right? I don't know. I feel like
I think and I think you're right. And I think, I don't know that we would have come out with a different decision necessarily, but I think we would have been eyes much wider open about some of the perils.
I mean, suffice it to say that when we did this again, almost 10 years later, we made we went about the decision-making process differently, which is why we're here today talking about it, right?
Yes. And so if in RFD 53, you have a explicit non-requirements, and so people were wondering, it's this is kind of a loaded paragraph based on past experience. The reputation of a system or stories about it being used by other organizations are weak data points. We will want to independently verify any properties we care about. That is a Postgres subtweet, such as it is. And that's more criticism of us, not Postgres. It's not Postgres' fault that we did not evaluate it rigorously. So, Dave, what did we find? Just to give and you linked to the postmortem, one of the postmortems.
So just to be a tiny bit more context, what we ended up doing for this metadata tier for high availability and horizontal scalability is sharded Postgres. Sharded. So we had in our initial production deployment, we had 3 shards of Postgres, and each of them was using synchronous replication with an async peer. So it was a primary, a synchronous peer, and then an asynchronous peer. And so for the high availability part, you are using the synchronous replication, and then you do a failover, and then the former sync is now the primary. And then for horizontal scalability, we built this whole consistent hashing system on top of it that would figure out for a given user key what shard its metadata should be on. But it's important to say that like that was a lot of engineering effort, like a whole lot. We spent on Manatee, which is the component for managing the high availability, and Electric Moray was the consistent hashing thing, and all the stuff around setting up synchronous replication, which is relevant because you don't have to do, as we'll get to with CockroachDB, like this is sort of a solved problem in more modern distributed databases, and that was an important factor. We didn't really want to go redo all that work.
That's definitely right. I also think that, my conclusion was like, Postgres is just built in an era when people go home at night, and and there are lots of design decisions that have been made in Postgres that are relying on the database getting some breathing room at some point and being able to catch up. And which was fine for years for us, and then it was not fine.
Yeah, so we were in production for several years and we had some minor outages that were basically due to insufficient auto vacuum in the compute tier, which we didn't really talk about, but we were also using the same primitives for the compute tier, and we would run into these weird cases where like pathological performance, like queries over like literally a 10-row table would take like 70 seconds because it had all this trash in it that the auto vacuum hadn't cleaned up, which is like, that's a whole complicated thing. And then we ended up having this 6-hour outage. I want to say July 27th. I don't know if I'm going to get the year right.
Oh God, yeah, you're right. It's July 27th.
2014?
2015. You nailed that. I mean, obviously, this is a date well.
It's not a good date. It's a bad one. I did not have a child born on this one, though.
That one was kind of crazy. So this was wraparound auto vacuum for people who may already be familiar with it, but what it boiled down to is it was a sort of latent bug in, I don't know, the configuration or the setup of the system or something that you'd only experience on the 200 millionth transaction of the database. Like, let that sink in for a second, because every time you hear about people debugging outages, it's always like, well, what changed in the last hour? And this is always my canonical example of like, the thing that changed was we ran a 200 millionth transaction since we had launched.
Right.
It's like
that was not something
confetti dropped from the ceiling.
And balloons all made of explosives.
And the behavior was hard hang for like 6 hours. And like we don't have to go into the whole thing, but basically we had a combination of things that were taking a combination of locks that was basically fine most of the time, but the wraparound auto vacuum takes a particular type of lock and holds it for 6 hours, or at least in this case it was 6 hours. And that prevented all the read locks from being takeable by anything in the system, and so the whole thing was basically stuck behind that. But okay, so this was like, these were the kinds of problems we had in the early years, but they weren't like, I don't think they called into question like, are we doing the wrong thing? We were kind of like, all right, these are kind of big things, but like, let's go spend some time understanding them and figure out how to fix that. I don't know. They weren't. This is a small compared to the stuff that we ended up hitting later. So I was going to dive into the Samsung era.
Yes.
So then Samsung buys Joyent, and in part to be able to deploy several much larger mantas. They were about 2 orders of magnitude larger than our production one. Was sort of what we were going for. And unlike our production one, there really were like 100% duty cycle. Like, I mean, there was like that in our production one, but it was less latency sensitive. Whereas with what we were trying to do afterwards, we are trying to do tons and tons of writes constantly for, days, weeks, months on end.
Yeah.
And that's where we started running into a whole lot of problems. And we got hammered on so many fronts in terms of especially synchronous replication, more auto vacuum. And like, this is where like, do we want to go in for 90 minutes? Because like, we found a lot of behavior around synchronous replication that was either undocumented or like very poorly documented, maybe not widely understood. And it contributed to feeling like this thing is really hard to operationalize. And even if you know about these things, they're very hard to work around or fix.
When you have this moment where you realize like, oh God, we are pushing this harder than anyone else.
Yeah.
And to give you kind of a very concrete example, I mean, Postgres had this idea that like, I understand where they came from, but it feels like an elegant idea of like, what is replication if not crash recovery? Like, where are we going with this exactly? It's like, well, it's the same logic to recover from a crash as it is to like replay a log that you've just been shipped. So let's use the same logic for that. And the problem is that the wall replay logic on the secondary is single threaded, and the database is massively multi-threaded, multi-processed. And it's like, okay, so if you're throwing as much work as you can at this thing, it's like you obviously can't keep up, right? And we would have replication would be like, I mean, days behind. The secondary is days behind the primary, and there's no real like blaring alarm telling you like, by the way, you think you have a replicated database, and that is true in the most academic sense, maybe only the academic sense. Because if you lose your primary, your database is going to be down for hours and hours and hours and hours. We
did have takeovers that took days.
Days. And the thing that was really frustrating is that and I think this is the part that like broke me a little bit on vibes as engineering methodology. When we talked to folks who deployed a lot of Postgres, they'd be like, "Oh yeah, what do you mean? Oh yeah," and we're like, "What do you mean? Oh yeah, like oh yeah, no, like this is a thing." It's like, okay, I guess validating, but what do you mean? Okay, but when we talked to you before, you're like, Postgres is great. Like I didn't hear any of these experiences. Like where, there's just such. It felt like, and maybe this is overly critical, but it kind of felt like it's an open secret in Postgres that like there are these ridiculously sharp edges and steep cliffs, and they they kind of undermine the narrative of Postgres being so reliable, so people don't talk about it. And then, I mean, I do remember, and you know who you are out there in the world, so I'm not going to name you. When we had someone, you know where I'm going with this, Dave. We had someone really pinned on this, and it's like, well, look, if you really want that, you need to deploy Oracle. It's like no, that's not. No, sorry, that's like no, that's not the right answer. Like you can't both say that this is a this is kind of a. I mean, there's this like major gap in, and like, I'm all for major gaps. It's just like we need to be upfront about it. But that's again, it's on us. We didn't do the testing. We didn't find those gaps until it was too late.
Do you think those are findable?
So I had this sort of surreal moment.
Yeah, go ahead, Dave.
I had this surreal moment at one of the Postgres confs that was in San Francisco. I think I went with Jan, and there was a talk about wall replication, or maybe it was about all the different supported kinds of replication. And I asked about this problem at the end, which we haven't really gone into the technical details of it, but it's basically, you have the synchronous replication apply lag that just builds up and it can't catch up because it's single threaded. And the speaker like agreed and referred me to the thing that we had built to work around this problem. Like you should check out what the Joyent folks had done with the PG pre-fault.
You're like, I am the Joyent folks. I built that.
I mean, obviously appreciate that like that was known and like people were now starting to talk about it, but it was also like how is this I do think it is worth a little more texture on this problem. So if you set up this was wall replication in Postgres. It's basically shipping the write-ahead log from the primary to the secondary. And there's two steps there. Three. There's one is sending the data, and there's writing it durably to disk in fsync. And then there's actually applying that to the live database that's on the sync. And it's synchronous with respect to the sending and writing to disk, but not with respect to the application. And so what would happen is you would think you were synchronously replicating, and you would be like, all the data would be there technically, but the apply lag you have what's called apply lag, which is this lag between what you have actually written to disk and what you've actually applied to the live database. But in order for that thing to become the primary, it has to have finished applying all those changes. And so when you would do a takeover, you'd be like, oh, by the way, I actually have 3 days worth of stuff to catch up on that it's very easy to not know. Like you were doing synchronous replication. Like how can you have a whole bunch more work to do? And it was just accumulating it for a long time. We called that secret lag, and then discovered many months later something that we call double secret lag, which is that there's a separate process called checkpointing, where it takes whatever has been applied via the wall and like kind of serializes a snapshot of all of the state to disk so that it doesn't have to replay the wall again. But our checkpointer also would start falling behind because it is also single-threaded. And so you could be fully up to date on the apply lag and then restart as part of a takeover. but you hadn't checkpointed in 2 days, and again, you have to go reapply all that stuff. And these were real gut punches each time we discovered this. And that one, there's not even a way to really monitor that. There's no, at least at the time, there wasn't a way to ask Postgres, how far behind were you on this? You could get it, but you had to run a command line thing. It wasn't built into any of the other monitoring tables that they have built in. So it definitely felt like, I guess it felt like a couple of things. There wasn't a lot of documentation around this, and maybe we were the first people to hit it seriously or to hit it this hard and hit these problems in the ways that we did. But the takeaway for us was certainly that it's not, you have to test it. That's what it boils down to. It's not, and you have to test it at high load, at high rate throughput, whatever it is you're trying to do. You have to do the fault testing under those conditions and see what happens. There's no substitute.
That's exactly right. No one cares about your workload the way you do. And
yeah, that's a better way to say
it. And this is why, I just don't care about anecdotal information on people running software. It's you can kind of point you in the right direction. Okay, I'll go, I'll add that to the list of things to evaluate, or I'll go decide that for myself. But even people's good experience, I know Dave, you and I are both scarred in the same way. Good experiences with software don't really tell me anything. Bad experiences, I'm curious about. That's interesting. Yes, because that actually happened.
The bad experiences are great because they give you a better sense of how far people probed and where they found the limits. And so, if you're well, you hit that problem, then that means you didn't hit these other problems or something. It gives you a better sense of what was working and also obviously what wasn't. But yeah, when people have a good experience, it's very hard to draw conclusions about that.
And on the one hand, it felt we got Adam in the chat who's basically blaming us for having deployed Postgres and not having realized that replication AJ are terrible. And it's don't worry, you're not the first, won't be the last. We know.
To be clear, other Adam, not this Adam. I just want to absolve myself of victim blaming you.
I thought it was more interesting to kind of leave it open ended. Just wonder, is Brian referring to Adam in the third person? No. I did ask my friends at Velocity, other Adam. I did ask my friends at Velocity. I asked all of my friends at Velocity, and that I did do. And no, it's no, that's wrong. Actually, the conclusion of you should have asked more people. No, wrong. What we should have done is tested it ourselves. That's what we should have done. And what my friends say at Velocity is only interesting in as much as it's pointing us to things that actually to go verify ourselves. And I do not care about vibes. I care only about. So that's, I would say, that was our disposition, Dave, coming into this because this was the other thing that was also a little bit. This is the only time I've been screamed at in my life by a colleague, not a joint, was over this issue. The stress levels were through the roof. People were extremely upset about this thing, and being told well, you should have done. It felt very frustrating, and it left a mark. It's definitely not going to do it that way. Very educational in that regard.
Yeah. So, and on the specific question of what about using Postgres again for something like this? It's true that a lot of this stuff has been improved, and there's I haven't followed all the stuff in the Postgres world. There's logical replication now and all kinds of other stuff, but there were so many other ways that the thing, how to describe? It was built from an era, like you said, where you have downtime, where you can go do a bunch of these maintenance operations, and you also got a team of DBAs that are basically monitoring this thing, or at least making sure that it seems healthy most of the time. There's vacuum. Upgrades are offline, for example. That's not a thing you can do online. If you're doing replication synchronously, you'd have to update all of them atomically, which you can't do, so you have to take that down. The protocol is not guaranteed to be backwards compatible across major revisions. There's all these, and it's not to criticize Postgres for what it is. It was built in an era in which those things were a lot less important, I think, and
that's right.
The zero downtime, easy horizontal scalability, high availability, all this stuff, it just wasn't as much of a thing. But more modern databases have been built in, with those constraints in mind, and that's kind of why we started looking around more broadly.
Yeah, and again, I think we're very happy for Postgres, and we want all the success in the world for Postgres. But but like what I have said about C++, where it's like, I want all the success in the world for C++, but C++ dragged my shit into the street and lit it on fire. And I don't care that it was 20 years ago. Like, I'm happy that C++ 25 years ago. I'm glad that C++ is like got its, has managed to straighten its life out. Maybe. Like, we're not dating. Sorry. So I feel the same way about Postgres. It's like, yeah, I'm happy for you, Postgres, but nope. We're just not, well, or it would be under very, very limited conditions where I knew exactly what we're getting ourselves into. So
one thing that I can't remember if I've if I even talked to you about this, Brian, but I talked to other peers in the industry about stuff like this. I mean, I kind of needed to while we were going through this as like therapy sessions. But people were telling me too that like they'd used other things like Cassandra and other databases that also, and they were never nearly as bad as what we'd experienced. But they would totally start kicking off some background operation, and then like
absolutely
would go to hell, and all kinds of horrible things would happen. And so that was another reason for me to feel like, okay, maybe all these databases have this potential and this problem, and then the trick is going to be figuring out where that is before it's a problem for us.
And we had our own Cassandra nightmare. We're like so we had a wholly separate nightmare, which ultimately ended up being a configuration problem. With Elijah's Dispatch debugged extraordinarily. Elijah and I worked on this for a long time together, and I learned a lot about Cassandra. And one of the things that, we had the preeminent Cassandra tuner consultant in, and we're looking at GC times, and we had like GC times, freeze the world GC times of like 110 milliseconds. I'm like, well, that's got to be, that feels like that's a problem. He's like, actually, that's pretty good. I'm like, that's pretty good. And he's like, I know, right? Who would think of writing a database in Java? And I'm like, okay, yeah, okay, right. But yes, I think that there's, you just realize that like the things that you care about in something may or may not be what the other people who are running it care about. It may not be what the people who wrote it care about. And that's the kind of like, you want to find that values match as much as possible.
Totally. And so we get to Oxide.
Yeah, we get to Oxide, and it's a new world at Oxide, and we've got a control plane that we need to go build.
And it's several years later in terms of like the industry development of distributed databases, right? There's this whole group of databases called NewSQL, based on Spanner, basically, that are like born in the cloud era. At least some of them with hands-off operability in mind, and they have things like high availability, online schema changes, rolling upgrades, automatic sharding, online contraction and expansion, just like built in. Yeah. And it's like, that sounds pretty good. Let's not go rebuild all those things that we had to go build on top of primitives that weren't really intended to be able to support that. So we looked around at a bunch of those, and I don't know how much we want to go into that, but CockroachDB was basically, I would say, the most appealing of those for various reasons. The big one was that it had a really strong Jepsen report. So for folks that don't know, Jepsen is, it was originally a project. I think it's now a consulting company that will basically stress test. Yeah, Kyle Kingsbury. It was stress test all kinds of distributed database-like things to verify their CAP properties. Their properties with respect to the CAP theorem, consistency and availability in the face of a partition. And a lot of them are horror stories. A lot of the reports around like all the terrible things that went wrong. And for some of the databases we looked at, some of these NewSQL ones, not only were there terrible inconsistencies in the data, but like the thing would keel over partway through the test and like not be able to be recovered. And those were obviously pretty worrisome. And CockroachDB's report was really strong here. So that was a big reason I think we were like, okay, that sounds pretty plausible. But then it also had a bunch of these features that just felt like it was actually pretty well aligned technically with what we wanted in terms of hands-off operability. So like with Cockroach, you basically just like run cockroach run, and then you point it at the other nodes of the cluster, and it just kind of figures it out. Whereas with some of the other ones, you would have to go deploy like 4 or 5 different components in a bunch of different places and get everything pointed at each other, which is fine, but like that's just a bunch more software you have to go build to make sure that all gets set up correctly. And you just kind of we didn't have to worry about that with CockroachDB. So that was pretty appealing too.
Yes, this is a really, really, really important point because I mean, we're not actually, we're not the first to do it, obviously, but I think it is unusual to ship a distributed system as a product. And it's also unusual to ship a distributed system as a product that works. So we are shipping a distributed system as a product that's going to exist over an air gap where we can't get to
critically no remote maintenance, no remote hands, right? Like it's got to just work. We're sending it into space.
It's got to just work. Yes. Which feels like it doesn't feel like you're splitting the atom with that requirement, but as you take it apart, it's like actually really, really hard because you're taking a lot of these systems have an implicit dependency on an operator. And I think in the cloud SaaS era, that's kind of more true than ever, honestly. And that is something that, I mean, Dave, that was very, very, very important. That the ability for these things to operate autonomously and automatically, and for us to be able to, through software, control their actions and not rely on an operator.
Yeah. Yes. Huge. Very huge. And I'd say that has worked out pretty well for us.
Yes. Well, I think it just, that is also where a lot of these other things fell down.
Yeah.
Where and I think that it's because folks have been asking, well, what about this? What about that? What about, and there was folks were asking about Yugabyte, and, Yugabyte has some strengths, for sure, in that it was definitely, it's purely open source, completely open source, which is great. And we kind of like the Postgres compatibility, seems nice. But the Jepsen report was a problem for Yugabyte. And we were concerned about some of the operability of it.
I think that was one of the ones where it crashed during the tests and required intervention to bring it back up, if I'm remembering right. And they fixed a bunch of those issues too. So it's not like these are just like permanent problems, but it was worrisome.
It was worrisome. And we looked at TIKV and TIDB. We had some similar kind of problems there. So I mean, with we had, and then we looked at Foundation DB. People were asking about Foundation DB as well. And I think, Foundation DB, we didn't dig into too deeply because I think we concluded that it was going to require us to build quite a bit. Is that right, Dave?
Yeah, that's right. So at that point, I don't think it even supported secondary indexes out of the box. That was something that people would build on top of it, which was fine. I mean, the takeaway was that it seemed like people had really great experiences and could build the thing that they needed, and had to invest quite a lot of engineering to take it from what it ships with in the box to what they needed. It really seemed like what the name says. It's a foundation for your database. It's not the complete thing.
And our constraint on this was that it was open source. So
I saw that. I mean, I saw that. I saw that again today for the first time since reading this RFD, writing this RFD like 4 years ago.
Yeah.
And I'm like a little bit like, I mean, it was BSL, right? I mean, that's not
open source, right?
Right.
Not open source.
It's close enough. It's close enough. It was just interesting to me rereading that like, oh yeah.
Oh, rereading 110 in terms of I mean, it's prescient.
Yeah.
So yeah, we'll talk about how Cockroach did on like its strengths, and this is it's outlined in 110, and then what were some of the weaknesses that we saw out of Cockroach?
Yeah, so I can pull this up to remind myself, but basically, we did a whole bunch of testing. We did online expansion, we did online contraction, we did an online schema change. I did basic sort of pkill, like send it a sigsegv, rebooted the operating system out from under it. I also panicked the operating system, which a lot of people don't realize is different than rebooting the operating system because TCP connections don't get cleaned up, so it looks more like a partition for a little while. And in all of these cases, not a high bar, but there was no data loss. That's pretty huge.
Yeah, good.
Not a high bar, but like pretty critical. I wrote no unexpected crashes. CockroachDB does like to crash when the clocks get out of sync. And this was the thing that I ran into a lot at first because our stock NTPD was not very good at keeping them in sync. And I gather this has been a pain point for other folks. But since we started using Crony, that's just like a complete non-problem for us. Crony keeps them well enough in sync that I don't think I've seen a single one of those crashes, knock on wood, since we started doing that. So no unexpected crashes. in this testing. Go see.
And Dave, I'd like to point out that I mean, you're such a model for us all in terms of the way you conduct your engineering. And one of the things that I loved about the way you did this, I mean, so much rigor with respect to not just the RFDs, but then the software you wrote for the evaluation, you got like in a repo, and a repo that has been closed. And in fact, you had archived it. And we opened it up as part of opening up 110 and 53. And I mean, this is delightful. And, the three of us were physically in the office together, and I was going into this repo, and I mean, I'd been in there, 4 years ago, but definitely not recently. And Adam was kind of roasting me for being so surprised about how complete it is. And, Adam was basically like, how dare you insult Dave by being surprised by the depth of and the polish on this evaluation repo. And then, Dave, you walked over and you were looking at it, and then it actually gave me great solace that you yourself were surprised at your own level of rigor in this work.
Well, yeah, in the write-up, I was like, oh, there's a lot of graphs here. Like, it does take a little while to to get that data out. But I thought it was really important.
ChatGPT was doing that for us.
Exactly, that's right. This is all a handcrafted, human-generated analysis.
Yeah, man. I wonder how ChatGPT would have changed that. Draw graphs of this random data. Go parse this. Figure out how to parse this data and draw me some graphs. Yeah, I mean, so the report was very detailed, and it's like, yeah, it has a lot. But I mean, that came out of the pain of having experienced this at Joyent, and in particular, some of the problems that we mentioned some of the really horrible problems at Joyent, but some of them were not. They don't sound so bad. It was like, okay, this auto vacuum was running for 3 days. Actually, auto vacuum's running for like a month on some shards, and latency is degraded like 40%. And you're like, okay, but like this thing that was taking 100 milliseconds is now taking 140 milliseconds. That's so bad. And it's like, well, if your goal is to move like petabytes of data from one place to another, it's like actually that's a huge decrease in throughput, and it's a huge problem. So it made me appreciate like how important it was to actually look at those graphs of latency, and also like the small spikes and dips and stuff like that too. Like those can have a pretty big impact. And I just wanted to see if we were going to see some of those same effects. And we did see latency degrade in some cases. Like, I'd have to go back to the data to look at where it was, like which of these operations it was. It wasn't for like failures, transient failures and stuff like that. But I think some of the expansion and contraction use cases would see these latency degradations. But it wasn't enough of a problem at the time.
Well, and we spent some time trying to investigate that, right? I think that those were
we
had some outliers. Yeah.
Yeah, we had 2 rounds of this testing, and the first round actually didn't go that well. Things would basically just stop for like 2 minutes or something like that while these operations were going on. And I think we concluded that they were CPU starved and maybe IO starved also. I can't remember. And we ended up, fortunately, we were able to just like bump up a bunch of the resource limits, and that helped quite a bit. This is also when I discovered what I feel like is crazy behavior on AWS, which is, I think, Adam, you were like completely unsurprised by this, but it was like, when you when you reboot a VM on AWS, you get like a whole bunch of IOPS for free, like super fast IOPS.
Yeah.
And the idea is basically they want to make booting fast. They like whatever level of IOPS you're going to get from a disk of a given size. If you were to boot a typical VM at that IOPS rate, it would be pretty slow to boot. So they just give you a whole bunch of IOPS fast up front. But they don't really know when you've booted, so you just get like a fixed number. It's like a whole lot of them. And so we had all these tests where it's like things are great for like 4 hours, and then all of a sudden it just craters. And it was because I just hit the limit that like however many IOPS they thought I needed for booting, I hit it 4 hours into the test, and then things cratered. Is that? I can't remember if that's actually. It must be in the write-up from the first testing notes. But that was crazy to me. I mean, is that something everyone just knows?
No, I think that's one of those things that you only learn the hard way. Like even as you're saying it, even now that it's on the podcast, now that we've told people are going to hit it the hard way and say, "Oh yeah, I remember Dave told me, but I had to learn it the hard way."
Yeah, it's also it's subtle because like there's nothing that goes off and says you hit this limit and now it's going to be slow.
Right. Oh yeah.
No.
Right.
You can tell, like if you go into the cloud metrics thing and like look up the throttle metric or whatever, like you can confirm that this is the case, and I did confirm that. But thank you for pointing me to that, Adam. But anyway, yes. So we did have to run a couple rounds of tests. We did find a couple of problems, but we were able to get to a pretty good point when we understood that problem and had the right amount of resources in each VM.
So one question coming from the chat is that in RFD53, it doesn't call out SQL per se, but it mentions that we need transactions and we need ACID semantics, atomicity, consistency, integrity, durability. And obviously Jepson would indicate that consistency is important to us. And the question is kind of curious about the reasoning there. Do you?
Yeah, so the consistency is sort of easier to think about. Like if you were using something like EC2 or any API where you're going to go provision a VM, it would be pretty weird if you could create a VM and then list your VMs and it wasn't there, or like create a VM and then get its state. Is it booted yet? And it's like, actually, I don't even know about it. So like, strong consistency was important for just the user experience of using our API and being able to configure things and getting a consistent view of whatever it is you had done. Similar example would be a firewall rules, right? If you imagined an eventually consistent API for firewall rules where you're like putting a bunch of firewall rules and then the networking in your VMs doesn't do what you expect, and you go check the state in the API and it's showing you something that's old or might be old and you don't know, that would be a pretty awful experience, I think. So that's why I would say consistency was really important. It's just what we wanted.
Consistency is really, yeah. And especially then it's just very, and this also, there are not so many elements in this database that consistency is unreasonable. This is not, this is not exabytes of data. So
that's true. That was a huge help, certainly relative to the joint use case. It's a much smaller database, and it's probably much smaller throughput. It's certainly much smaller throughput now, but I think even for a long time, it probably will be.
But we care a lot about it. We care about its consistency. We care about its availability.
Yeah.
And because if it's not consistent, there's just, or it's eventually consistent, that just casts such a long shadow up the control plane, and
it
just
really
end up with. And then it's like also, I mean, how do you if it's not there, just like wait a little bit? It's like, well, okay, so at what point is that kind of pathological? It's like, I don't know, I guess you got to wait a day this time. I don't know, they're not. And I mean, then you are kind of like training yourself to not really explore provisioning failures or long tails of provisioning. We want provisioning to be really quick, really robust, and to always succeed or fail very explicitly. Like we don't want to have that kind of GUI property that it's like, yeah, it's kind of in a bad mood today, so maybe like, go take a walk and see if it's done. It's like, no, thank you.
Totally. The sort of transactions it's a little bit more abstract. I'd have to think about a better example, but like some examples would be, if you provision a VM, we want to find the resources for it, which most basically includes like the sled we're going to put it on, and we want to allocate those resources. And that's a complicated decision. Actually, disks are even more complicated because we need to find 3 sleds that have enough storage on them and that storage needs to be on disks that are currently in service and believed to be working and blah, blah, blah. So it's like a complicated set of constraints. And then there's like an optimization around like which of the sets of ones do you want to actually pick, and then you want to commit to that. So like that looks like a CTE in SQL where you're basically fetching a bunch of state and then picking a couple of them and then like committing that state in the database. So that makes sense, I think, why that would be in a transaction. Another example.
Can you explain what a CTE is in SQL?
Yeah, CTE is a common table expression, and it's basically a way of doing I think of it as a way of doing a bunch of things in sequence in SQL, because SQL is sort of declarative, where you're basically like, if you're writing a select, you're describing what you want the output to look like, but it is useful sometimes to be able to give names to some of the intermediate values. And so what a CTE lets you do is like with some name as some query, go execute some other query that uses that name in it. It's like kind of a basic thing just to be able to do a bunch of things in a row, basically. And they all happen in a transaction. Maybe I don't know if this is a better or worse example of using transactions is that I'm working on a system called Reconfigurator where the system basically, it's kind of like the reconciler pattern. We talked about this a little bit last week, where the system is looking at the configured like what the operator has configured, what they want the system to look like, and what it actually looks like, and making a plan that we call a blueprint that's like moving forward to the next step. And so the Nexus instances, the control plane instances, are looking like potentially independently looking at that and then making a decision about what should happen and trying to create a next blueprint. And then they will try to make that the next blueprint that the system is trying to work towards. But it's conditional on other things not having invalidated those choices. So that's where we also want to use a transaction to say, basically make this the new target blueprint if this other one is the current target, because that means nothing has changed since I made all these decisions. So that hopefully that makes some sense in terms of like why we're using transactions. There's just a lot of decisions like that.
Right. And another, an example of where consistency is really important, actually. And cue our episode from last week in terms of sagas, where it'd be really hard to do that without transactions and consistency.
Yeah.
So what have been kind of our experiences? So we decide to go Cockroach. What were some of the drawbacks? We got the thing working.
If I can just add one or two more things to the testing that we did that I think were really huge.
Yes.
The cluster always converged to the right level of replication and came back online without operator intervention, no matter what I did to it. That was really huge for me. Having just come off of a couple of years of fighting these issues, that was really huge. And it also clearly communicated when data was under-replicated and what it was doing to fix it and like what the progress was like on that. And it was just, there was a breath of fresh air compared to what I had been doing. So that was huge.
When it tells you that we're in the kind of the design center for this thing, someone has cared about that kind of tooling and that kind of visibility.
That's right. That's exactly right. It made me feel like the people who built it understood some of the complexities that at least we didn't understand when we chose Postgres for the joint use case, and that made me feel better about it. And the experience, I'd say, has been pretty positive. I don't think we've had too many major issues with it. The couple that come to mind, Ben and I ran into some horrible problem around partial indexes being corrupted, which turned out to be a known issue that had been already fixed in the latest version, and we were able to upgrade to it, and like that was great. It was good to know that they had already found it. It was scary, and I did this demo at Demo Day, where I just did a bunch of selects and updates in such a way that it produced obviously wrong data. So that was definitely scary, but they've taken it seriously. They'd had a Cockroach technical advisory for that. I think that was the point where I started subscribing to those and making sure that we were aware of all those kinds of problems.
Do you have that issue? Or do you? We'll dig that up.
I can definitely dig it up. The other one is client-side retries were a thing we had to go figure out. And this is a little different than Postgres. I think so. I'd have to actually think about that. So CockroachDB is generally Postgres compatible, but it is distributed under the hood, and everything you write goes through Raft and winds up on a couple of nodes. And you can have failure modes that are at least much less common than on Postgres, where you are trying to make some change and CockroachDB you're trying to make some change that ends up spanning more nodes than a simple change would. And in that process, some of the stuff changed out from under you, and the thing you tried to do is no longer valid. Does that sound like rambling, or did that make any sense?
Yeah, it makes sense.
It's a little bit like optimistic concurrency control. It's not exactly that, but what's happening under the hood is it's basically making a bunch of changes conditional on the underlying state not having changed on the other node. And if the underlying state does change, then it basically aborts the transaction with an error saying, sorry, you just need to do this again. And if you run it again, it should work. Which is a little cheesy, but it's a pretty pragmatic trade-off, I think. Because the alternative is to try it by itself, and then you have silent latency bubbles. But it actually can retry it by itself when they are simple transactions. Like if you're able to issue the whole, begin, select, insert, update, whatever, commit in one go, then it can retry it by itself, and you don't have to think about this at all. But we, for better and worse, use a bunch of this pattern that I call interactive transactions, where in Rust we will write the begin transaction thing, and then we will go issue more SQL. But our client is involved in that. It's not like we're issuing all that stuff to the database at once. We're having a conversation with the database with the transaction open, and then committing it. And that opens you up to a much longer window where this can happen, and it also means that the database can't retry it by itself because it can't replay that conversation. It doesn't know what you're going to say. You know what I mean? It doesn't know what SQL to replay because it was dependent on whatever results you got back from earlier queries in the same transaction. So that was a thing that we had to go build some mechanism for that. And I mean, I don't know if I'd say pain point in terms of our usage of it more than anything, because it is actually pretty well documented that this is a thing and that there are these two ways of dealing with it, and you might have to invest some client-side work if your language doesn't already have it. And then we had to do that.
And then so the autonomous operation has so far been okay. We haven't had.
Yeah, I'm trying to think. I don't remember. So I would say we probably don't have enough monitoring to know that it's not crashing transiently and like coming back really quickly and working. You know what I mean? But I don't think we have like dozens of core files from production systems. We certainly I cannot ever remember getting to a system where Cockroach was down and we couldn't bring it back up, or even where it was down.
Yeah,
I think it's just basically stayed up. And as I say that out loud, it makes me worry that we're not, that the things we're trying to do are just in its wheelhouse and we haven't hit it in the places where it's not ready for it. But that's helpful enough, right? And this
we don't trust anecdotal evidence, including our own anecdotal.
Absolutely. But that was never true of Postgres at Joyent. Even in development, all the time we'd run into cases where it had just decided replication was broken and you had to figure out what was wrong and then manually fix it. So there were tons of cases where it would just fall down and not come up without your intervention, and that just hasn't been the case. So that's been pretty good.
And Dave, the two places where we have been questioned data integrity turned out to be not related to Cockroach at all. I think one was when you came on the show 2 years ago to talk about, as I recall, the YMM registers, and basically a gap in our operating system in Helios. And then the other one being a misunderstanding of cancellation with Rust async. And both of those kind of looked like data corruption, but it was not the Cockroach's fault.
Yeah, that second one was very wild. And so that one was, we walked up to a system that was broken. I think it was our pre-production system, our dog food system. And its log had indicated that it had done a bunch of work that was not in the database. And it's simple enough code that there was it's an insert only thing, nothing ever deletes anything from it. It's how can this not be there? And that turned out to be a client-side problem where our connection pool basically had a bug where we would check out the connection, we'd begin a transaction, then we'd encounter an error that would cause Rust async cancellation to happen, and we weren't aborting the transaction. And so anything else that tried to go do something with that connection was operating in the fantasy land in which this transaction was going to complete.
It's like an alternate universe.
It's absolutely. Right. And which is actually kind of amazing.
Different timeline.
It would run for hours like that. And that's kind of a problem. I mean, I don't know that Postgres would have done worse with that, but it's a problem for the client, but it's also a problem for the database because you end up having all this data that is sitting there, not referenced by anything, but it still has to hang on to it. And if you decide not to do anything,
this is a hell of a transaction you guys have going on. But all right, yeah, another one. Come on in.
I'm using a terabyte of storage and hundreds of gigabytes of memory for this thing. Are you sure you want to do something with it?
Are you going to close this transaction at some point? All right, whatever.
All right, no, I guess not. All right, give me some more. It's fine. I'm here. Yeah.
That was a big eye-opener for us about cancellation, but fortunately, even though it looked for all the world at first, oh my god, has the database completely eaten everything?
Yeah, did you kind of lose your breath a little bit when you first realized it's not in the database? You're just oh god, it's happening again. It's like data corruption week was last week. It can't be happening right now.
Yeah, that was.
Yeah, it's Adam. I totally forgotten about the transaction being left open because it's certainly the debugging odyssey that Dave you described 2 years ago is I think because there was also some vibes online of self-supporting on a database that should keep you up at night. Well, you should go listen to this and I mean, we're kind of we knew, and I actually think this is kind of an important detail about the decision around Cockroach. And Dave, I thought it was very interesting because you're very prescient about this. In RFD 110, we knew we were self-supporting at the outset. We were not. We knew we're running it first of all on an Illumos derivative in terms of Helios, and it was very. I mean, we were having to do a lot of work to get it to work there. We were using the open source builds. Dave, a lot of the things that you've found that have been busted have kind of been like little things with the open source build. Is that correct?
Yeah. So the context here is that it's been since we have used CockroachDB, i.e., not just for the last week, it has had parts that were proprietary or more proprietary, I guess, and parts that were more open. And we had decided early on we wanted to stick to the open source stuff, and they had a build target for that, which was amazing.
Yeah.
I was like, that's perfect.
It was very helpful.
So we can go build just the OSS thing and know that we're not accidentally using some of these features that then we'd be in violation of their license. So, but occasionally they would break it. I don't think they were testing it that heavily. I'm not sure if they just didn't have a CI for it or something. But yeah, I found a couple of issues like that, but they were pretty good about fixing them.
And I think that part of like when we were when people wonder like why would you adopt beautifully licensed software? Well, part of it because like they did have things like this that made it easy for us to not accidentally trip over into their CCL, poorly named CCL, the Cockroach Community License, which is basically like proprietary stuff, basically. And their Bucel clause was pretty crisply defined. So there were a bunch of reasons why it's like, no, this feels like this is not OSI approved open, but it is actually sufficiently open for us for what we need to go do. And then again, we know we're born self-supporting on this. We're just not going to get help is not on the way, which is one of the many Oxide mottos. We for many of the things that we do, we are very much on our own. So we were not, and this is no different in that regard.
Yeah, I mean, I should say we filed a bunch of issues with CockroachDB, and working with their engineering has always been a pretty positive experience, I would say. And also, we all know from our experience that our use case, our platform is different enough that, what did you say earlier? Nobody cares about your workload like you do. Like, we're not going to get we're not going to have the experience of like, we can just write to you with this issue and you're just going to be able to fix it for us.
Right.
That's not been our experience with other software in general, but also on our platform and in this use case. So like, yeah, we were going to be self-supporting to a large degree, but hopefully with the help of the engineering team, and that's been pretty true.
Right. We've been, because even when we had, we had this issue about where we had to go very deep on the YMM registers not being restored properly, and we did reach out to them, and they were like reasonably, they were as earnest as you could kind of expect them. I mean, and they were kind of reasonably saying like, this, I don't know, might be an OS issue, but it felt like they weren't blowing us off. It felt like we were being taken seriously, which is great.
That was wild because that particular issue could cause all kinds of bedlam, like absolutely all kinds of can't happen bugs would happen. And so before we figured this out, I wound up filing like 4 or 5 different bugs that were like, from their perspective, somewhere between you got pretty unlucky in some race condition and this really can't happen. And as you said, they replied to them all pretty earnestly. They were like, okay, well, you are seeing this, so here's what I would try. Here's what I would go validate. Go validate that the Go test suite passes on your system, or that this memory test works, or whatever. And it was helpful. It wasn't just like go fetch rocks. It was like actually helpful stuff.
And a question in the chat about how we're feeling about CRDB written in Go. Go is obviously not our first choice for things. A lot of CRDB is written in C++, which is important. It's not merely Go, but I think it's, on the one hand, not great. On the other hand, it's something that we need to work on the platform. So I think it's kind of helpful to have a current use case for it. I don't know, Dave, what do you feel?
Yeah, I mean, definitely didn't feel great. I don't like it, but I'm not going to not use something because of that. I mean, in the course of debugging that horrible signal handler YMM thing, there were a lot of cases where I spent a lot of time with the Go memory allocator, and there's an awful lot of stuff that was runtime invariance that could not be verified at compile time. And I was thinking the whole time, like, man, if this were Rust, like this just couldn't happen. But I need to rule all these things out because I know this thing is broken and I don't know which of these things is broken or why or anything. It was definitely like a whole lot of convention, I guess is what I'd say. It was like working by a lot of convention, like a lot of C code bases do, right? It's like everyone has to use this function correctly. There are 100 callers. I'm going to go check them all, you know?
So it is all... It's also worth mentioning that one of our challenges with Cockroach is that it has been robust enough that we're kind of far behind. And Ileana's got a great RFD. Ileana, I will make that one public. I didn't want to make that one. Ileana was out on vacation and it felt unsporting to make someone's RFD public when they were out. I don't know. It just felt like, talk about social contracts, Ileana. I just felt like I would be violating one if I made 469 public. But I did. There's nothing incriminating in 469. I just wanted to kind of get your blessing. So Ileana's given me your blessing. So I will make that public later today here. But one of the things that we had is like, okay, wow, we're really kind of far behind. And we needed to find a way to kind of catch up. Because I think one of the things we were concerned about, and it actually highlighted another constraint I kind of mentioned at the top, that like we actually need to support kind of pretty old versions of this stuff. And we're on 22.1.9, right, Dave? And yeah, I think isn't that like out of their support window, even if we were born self-supporting, but I think that's right. I think that is too old, which actually in this case has been, I think that has actually been helpful to us because they are not, I think that it is the supported releases that are being relicensed. If it were supported, it would also be subject to this relicensing. I would say, because I didn't mention this at the top, I don't like the fact that the patch releases are being relicensed. And I think that is the one bit of this. There are two bits that, such as there's a social contract between Cockroach Labs and Oxide, or Cockroach Labs and users of CockroachDB, of the open source variant of CockroachDB, and or the general public. There are two kind of social contracts that I think are being stretched a bit. One, I don't like the fact that the patch releases are, because the patch release, you're taking a release that was first released, a year and a half ago, and you are now like, there are potential regressions in there. And the fix for the regression is now going to be proprietary. And
or like a security update, like that kind of sucks.
Security update, I know that just it sucks. And I do think, like, I don't think that's okay. I don't think Cockroach Labs should get a free pass on that. I think that does tear at a bit of the social responsibility. Like, if you didn't want to do it, you shouldn't have open sourced it. And so I think that is.
I think that's what they're saying too. Like, we shouldn't have open sourced it.
Right, this guy gets it. This guy gets it. That's what our blog entry says. Practically, that was a line in the blog entry. We shouldn't have open sourced it.
The prevailing thesis. Yeah,
I know you did open source it. That's the problem. You did open source it. So I think that is not great. I also think, and I sorry, this is the other one that I did not say at the top, but I also think is not great about this. All of the blog entries and the discussion of the move to the Bucel in, I believe, 2019 has all been deleted. And I think that's lame.
I think gross. Yeah.
Because I think that, like, look, you had a bunch of rhetoric in 2019 about how Amazon was, and it was called out as Amazon over and over and over again, that Amazon was taking your project and turning it into a service, and that you had to punish Amazon with this clause. But like, that's okay, that's not where we are now. So clearly, like, this is not about Amazon anymore. And I just think, like, just own all that and just say, like, yeah, that was then and this is now, and like, this is like how our thinking has changed and expanded. And I wish they would be a little bit more transparent about that. I think that's a bit lame. But again, I don't think that they because the other reason I think that it just to be clear, they definitely don't owe us anything. Because, like, also, Cockroach could be, when we make the decision to play Cockroach could go out of business, right? And that did happen to, like, RethinkDB, rip RethinkDB. Adam, do you remember me during my RethinkDB? I know Dave was like, oh my God, you were insufferable.
Yeah, no, I wasn't gonna bring it up because it was so embarrassing, but no, I remember how excited you were. I think there was general excitement.
I really liked RethinkDB, and and RethinkDB was and they had like a model that is like not an unreasonable model of it's AGPL, and if you want not to be AGPL, then contact us. And like, well, I'm using this for this cored up database for Thoth, and but RethinkDB went out of business extremely abruptly, and left. It doesn't matter who you were, like everybody, whether you're a commercial customer or an open source user, you're like, okay, like with that now we're, what now? And yeah, Adam's linking to the on the CNCF, and I really am grateful to Dan Cohn, who has since passed away, but Dan, who was the executive director of the CNCF, also was like, oh my God, it's like folks that are using this are now really stuck. And Dan went and found the folks that had bit the investors, because I mean, RethinkDB really went into the side of the mountain.
It went quickly, right? Like very quickly.
Yeah, it went so quickly. Yeah, free startup advice. If like the VCs aren't paying attention, that's not a good thing. That's a bad thing. And the VCs had kind of mentally zeroed it out, and I just don't think the executive management over there realized it. And by the time they realized it, like the altimeter was the terrain was coming up, the warnings were blaring, and that thing just like went out of business within like very abruptly. And they found one of the investors who had received all the IP Dan did, and he's like, actually, I kind of know these guys. I should just call them up. And they had no idea what they had. And Dan bought it for. Did I put the dollar figure in there?
Sure, you did. What was it? Remind us.
He's like, yeah, don't read the blog entry. I'm sure it's in there. Just tell us what it is now.
No, it's in there for sure.
No, I was going. So I think it was like they wanted 1.5 million, and Dan's like, "How about 5,000?" And they were like, "How about 10,000?" Dan's like, "Sold." So and again, Dan has unfortunately since passed away, and Dan and I didn't see eye to eye and everything, but I was always incredibly grateful for what Dan did for the RethinkDB community, and I just like just getting it out. I mean, even if it was lived only as kind of an artifact that people could now just like freely borrow from, right? If there's value in there, you can, and it's there, it exists. People can use it. It's not something that is current necessarily, but so that can happen too. Like if you're using open source, like you just can't assume that like and a commercial entity does not have an obligation to you to exist. Mm-hmm. And they can fly into the side of the mountain, and you can't really have like, what are you going to have, like a blog entry explaining how they shouldn't have flown into the side of the mountain? It's like, yeah, they know that. So you always have to know that the self-support is going to be, that's what you have to take that responsibility.
And that is one of the benefits of open source.
Yes. Extremely important is that and I think that, and again, Adam, you and Dave and I have been through a couple iterations of this and have seen software survive the corporate vessel that it's in. And so the corporate vessel separating from the software is not as shocking to us as it might be to other people. And it's also not as foreclosing as it may be to other people. The idea of like, oh my God, like you'll never self-support this. It's like, yeah, go listen to our episode on Board Bring Up. We're not worried. Mm-hmm. Not to minimize how hard it is to support a database, certainly, but I feel we can do it. I think that I think we said as much in 508 that we intend to allow other people to run Cockroach as we're running it. That does not necessarily mean it's a community fork. I don't think it'll be interesting to see. I'm not sure if a community fork is going to spring up on this one. I got to tell you, I'm not sure.
Yeah, unclear. I mean, I've not seen a bunch of noise about it. I wonder what the community use of it is like.
Yeah, so Dave, I guess maybe to bring us up to the present, I mean, what was your kind of reaction to the news? I mean, did you see this coming? What was your thought on Thursday morning? How did you learn about it, actually?
I checked my email like early in the day. Like I might have just been in bed, just like open the phone, open the email, and I had an email, I think from the CEO. I mean, it was a blast email to everyone who was on any of their mailing lists, being like, great news for everyone who's using CockroachDB. And I was like, oh no.
Oh no. No,
I mean, it really was
not
like
great
good news, everyone.
Good news, everyone. Oh, totally. Yeah.
And definitely disappointing. I mean, I understand, they're making an argument that like this is better for a lot of people who want some of the enterprise features, but could never have gotten an enterprise license, and now that may be sort of free, I guess, but you still have to get a license key and like prove that you are entitled to a free one. I don't know. I mean, it seemed from the Hacker News thread that some folks anyway are pretty happy about it. I don't know what most people's experience with it is. I was definitely not happy to learn of this.
I'm embarrassed that I did not get the email because you're on their lists and I'm not. But I'm embarrassed to say that I learned about this on Twitter from Adam Jacob. So Adam, I'm like, I look at Adam, I'm like, oh no. And then I'm like, I wonder if anyone's talking about this internally. Of course, everyone, by the time I'm like, okay, I should have gone to water cooler first. Everyone has been, Matt Keeter, I think had seen this very early in the morning and had ice on the East Coast. So, people were all avidly discussing it. I'm like, all right, I think my first movement in the morning should be probably to our own internal chat and not to Twitter. But Adam, there you go. You're a news agency. And then in terms of our options, just to bring it back to kind of 508, Dave, I mean, I think what were your thoughts in terms of our options there?
Well, gosh, I mean, from first principles, we could obviously like rip Cockroach out. That's one option.
Ugh.
An incredible amount of work. And it is basically working for us. So, that suggests option 2, which is to just jump off the train at the point we're at. Sort of related option is upgrade to the latest free-ish thing that we can, and then jump off. But you raised the point that you raised earlier, which is like there's this real risk that in updating to the latest, we encounter a new problem. I mean, it may not even be a regression, right? It might just be some change in behavior that happens to be broken for our workload and like not be able to get the fix, which is pretty scary. So, we kind of concluded on it. And, you could probably speak more to the option of like, we'll just pay them and license it. But you kind of talked at the top about why we don't really want to do that.
Which doesn't foreclose all commercial relationships, by the way. And there may be, I think in my kind of ideal world, there'd be a commercial relationship that allows us to get like some of those patch releases open source, or I don't know. I think that we'll see. But I would love to have a way of getting us to something that is because we have seen issues that were, we've seen the upgrades have been good news for Cockroach, not bad news, which is not the case for all software. And then someone's Ileana had said in the chat that I think very aptly, like it's going to be hard to self-support a database, but it's not the hardest thing we've done. And someone's like, all right, well, what metrics do you use for that? And which is a very valid question. I would say it's not the hardest thing we've done because it doesn't feel like existential risk. And we've got an extraordinary amount of software expertise at Oxide. We've had some really scary things that did feel like, well, if we don't find this, if the NIC doesn't come out of reset, like we don't have a company, or if the CPU doesn't come out of reset, we don't have a company, or if we can't get that lowest level of platform enablement software working, we don't have a company. And so we've had some things that have been really, really scary. But we've also, I mean, God, I'd be love to get your perspective on it, Dave and Adam. But I feel Alan Hansen, our colleague, has pointed this out a couple of times that every time we knock one of those things down as a team, I think it improves. It gives us confidence that we can knock down the next thing. And I don't think it's. I just feel like, man, if we pull together and like we can do it. We can figure it out. Which is not to say like it could be really, really hard. And but if it's really hard, I mean that's podcast content, right?
Now you're talking.
I gotta tell you, as someone like Adam's looking at the numbers, he'll tell you stuff kills.
Yeah, and like I totally agree with you, Brian, and agree with Alan's sentiment there. And like this is not to diminish the complexity of these things, but we're pretty good at software. We're pretty good at debugging, and Cockroach has been great. It's been very solid for us. So
I mean, that's the other thing. Is like we've been running this stuff in production for years now. Like it's not. It's. I mean, I guess tomorrow we could have some horrible, impossible to debug problem, but like it
obviously will. I mean, so
we're chasing it pretty hard.
We're sitting here like on our knees begging for it, and the gods are like, "This guy again." Man, how many times do we have to punish this guy before he stops doing this? Like, oh, order it up.
Mean, if you're going to make this judgment about like how much work is it going to be to support this thing based on the last couple of years of self-supporting it, like, I mean, you would look to that, right? And it's like, well, we actually haven't spent that much. The most effort we spent by far was what turned out to be the OS bug.
Yeah,
absolutely.
Well,
by like an order of magnitude or two.
Not only have we not invested much, we haven't even sort of taken the time to upgrade us to a more modern version. In part because we haven't had to, and then that turns out to be pretty lucky, where it's going to roll over to be Apache 2 in 9 months, as opposed to multiple years if we had been a little more diligent about upgrading.
Absolutely, we've got. So I mean, the fact that it is actually going to be that we are with every passing day, this is getting closer and closer to being. And again, we're not worried about the Busel. They've constructed that clause well. We are not violating it. It would not be. So we're abiding by it. It's all fine. But boy, it being Apache 2.0 would be great.
Totally.
Yes. Did you see Stephen O'Grady's tweet on that? That was pretty funny. Which is like,
what do you say?
It's like, well, Oxide would be the first company that would be deploying something that basically had timed out into Apache. That again, once again, Oxide goes its own way. Like, you bet, baby. Oxide goes its own way.
The Busel, I had previously thought that that flip over to open source was kind of baloney. It was kind of window dressing. Like kind of thinking, well, who wants 3-year-old software anyway? But turns out
people running 2 years and 3 months old software actually are counting down the months to 3. Yeah, totally. I feel the same way. I felt like, and actually, you know what? It was funny. It's like I actually thought it was 5 years. And it was only when Matt, I think in our internal chat, was being like, "Oh, wait a minute, and was doing the math." I'm like, "Wait a minute, it's only 3. Oh, wow, 3 years feels like a really long time, and is in some regards, but like is not." So, so I think that our path is pretty clear here. And Dave, I felt like that was. As a result, like this just doesn't feel that anxiety producing relative to the other crises.
Right. I think that's the other thing. It's like you could reasonably ask, like, is this the 10-year plan? Are we in 10 years going to be running Cockroach 22.19 on the Go version that's there? And like, I'm sure we will run into problems. Like, the TLS that is in there is no longer allowed by any of the clients that we want to use or something like that. But like, these are not, oh my God, we need to rip everything out and rewrite how we use the control plane data store problems. You know what I mean? These are like, okay, we'll deal with those problems when they come up.
That's right. We got some work to do. But we always have some work to do.
When a customer has 100 Oxide racks, spanning multiple geos, and are we revisiting the decision? Like conceivably, like when that happens, sure.
Yeah, I mean, and Andrew, I'm not sure if Andrew is lurking, but our colleague Andrew Stone is just like itching to write the RFD on what he's like, because we will. I mean, like the next step for us, unless if we hit something that invalidated Cockroach with a new use case or what have you, I mean, we'd probably like go back to the rubric a little bit, Dave, and I think it would be, I think we would kind of reevaluate everything at that point, and who knows what that world would look like. And will we be writing our own database before or after we're doing our own ASIC? Only time will tell. These are two things that we believe we will do in the fullness of time, but not today. Well, Dave, this was great. And great to talk about the kind of the whole rubric. I really would encourage people to check out not just the rubric, but all of the evaluation you did. I really do think it's a model for NS Dave, especially because you didn't like think of this as all being public, but I think our disposition is to get as much of the stuff out there as possible.
If you really go digging, you can find my day-to-day notes and all the stupid missteps I made along the way. I discovered them there. But
I also
it was actually fun going through the history again.
It was fun going through the history again. Yeah, it was fun, and just because I also feel that like damn, this analysis is really good. And then you were like, God, was it? Because I don't remember at the time. You're like, am I spending like too much time on the analysis here? It's like, no, definitely not. This is an extremely good use of time, and gave us a lot of confidence in the decision. And I think it's been terrific to get these RFDs out there. And thank you for both 53 and 110, two RFDs that I definitely like appreciated at the time. But there's always like the RFD that you read and you're like, oh yeah, this seems great. And then all of a sudden something changes where it's like everything's load bearing. In some cases, like for me, that's like, okay, I'm actually implementing this bit now, or like now this has become an issue that is a hot issue the way it is with Cockroach. So now I'm like reading every word of this RFD. I would love to tell you that I read 110 as closely then as I did after Thursday, Dave. But and just reminds me, yeah, this is really good. What's that?
I wouldn't blame you for not, the first time around.
Well, just like just because like your metric is totally different, right? In terms and it was just great to go back and reread all that. It was also great, and this is a segue, a teaser for Adam. We are doing something nearly unprecedented for Oxide Friends. I'm not gonna say totally unprecedented.
But I think it's only maybe happened once or twice before.
It's happened once or twice. We are scheduling an episode in advance, only 1 week in advance, but still, I mean, it's pretty amazing.
A whole week, yeah,
a whole week, an entire week. Of course, this is going to be the week that like Oracle acquires Broadcom and they both merge the Linux Foundation or something. And there's something, something absolute spectacularity is basically guaranteed this week. Eric Schmidt's going to shoot his mouth off again. He's going to go off and be more extended diatribe. He's going to be like, oh, wait a minute, Oxide and Friends can't talk about it on Monday? Okay, I want to get back to that return to the office thing I was getting on.
That's right. It's a good time to bury all your news, folks.
Bury all your news. Get it out there now. But we are going to talk about RFDs, and we're going to talk about the why we developed RFDs, how we've used them, but very importantly, we're going to talk about the actual the mechanics that we've developed. And our colleagues Ben Leonard and Augustus May are going to join us. I'm really excited about that because something that was really important here is our ability to make individual RFDs public, and that really relies on the RFD site, which has been great. And so we can go through and share this stuff with you. And that's been really, really helpful. And it's been our disposition for more and more RFDs. Although we do wait for people to get back from vacation. So, Leon, thank you for your blessing. But really looking forward to that one. And Adam, because Ben is in the UK, and you are going to be in Europe. So this is going to be a European-friendly episode on RFDs. So we're going to do it at 9 a.m. Pacific on Monday. It's going to be, which I understand to be 5 p.m. in London and 6 p.m. in Europe. So
allegedly, yes.
Allegedly. So I apologize to all of Europe for having to catch us on time delay or in Traneg waking up at 3 a.m. or whatever it is in Armenia. But this is going to be a great one. I'm really looking forward to that because that RFD site has been really, really important. There's someone saying in the chat, it's gorgeous. It really is gorgeous. Looks great on mobile. And there's a lot of technical meat behind it. And then that's been extremely important for the way that we do engineering. I think Adam, as you and I are kicking around titles, we are calling it the backbone of Oxide.
Yeah,
it really is.
It really is.
All right, Dave, thank you very much for joining us. But you should join us next week too on RFDs, man. I'm just I know, but really, really appreciate you joining us in the evening hours here.
Thanks for having me. It's been great.
Really great stuff. So on the one hand, it was a bit of a downer to get the news, but on the other hand, I think it was a real opportunity. When one door closes, another door opens, and it was great for us to be able to get all this stuff public out there, describe what we're doing, and really know our own fate. It's always nice to know where you're going. So. All right, Adam, when we talk next, you will be on a distant shore, and we will be talking RFDs.
Looking forward to it.
All right. Thanks, everybody. Talk to you next time.